Hi, my name is Diego Tinoco, and I'm a student here at University of Vernon. Today, we're going to be talking about an exciting lab called "It's All in the Cross-Linking Making Slime." To begin, I'm going to explain to you the difference between a monomer and a polymer. Our monomers are just many smaller groups that together make macromolecules. Our polymers are made up of the monomers that together, when they link up end to end, they're going to make a polymer. For example, if you take a train and each individual cart is a monomer, once they are linked end to end, together will form our polymer. Now, I want to talk about our cross-linking agent that we'll be using for our lab. A cross-linking agent will form chemical bonds between our long polymer strands. If our cross-linking agent is not present, as you can see here on the left side, each polymer strand does not interact with one another. They are all around each other, but they do not interact at all. Once we introduce our cross-linking agent into our solution, as you can see here, each polymer strand will start making chemical bonds with one another. And in our lab, our cross-linking agent will be borax. Using borax, we will be making our slime. I'm making slime as a kid. And right about now, you might be wondering, why slime? As a college student, why would you be making slime? Well, now we will dig deeper into what happens chemically when making slime. In this four-part lab experiment, starting with part one, we will see how properties of our polymer strands change when reacting with our cross-linking agent, borax, creating what we want, slime. In part two, we will titrate with 1 molar HCl using a microburette to kill our slime, undoing the reaction between the polymer strands. Once we have killed our slime, we can move forward into part three. Like a mad scientist, Victor Frankenstein, we will revive our slime by adding our cross-linking agent again. Once achieving our reanimation, we can proceed to part four of this experiment, which is going to consist of repeating parts 1 to 3 using a 4% PVA solution that has a different molecular weight. By doing so, we can observe, if any or none at all, properties of our slime changed. In other words, we're going to repeat the experiment and revive a different patient and look for any change. Now let's talk about what we are going to need for this lab experiment. Here, you can see I divided our equipment and our chemicals. For our equipment, we are going to use our volumetric auto pipette. We're going to use a microburette, a plastic pipette, 2 tongue compressors, 1 50 ml graduated cylinder, 1 250 milliliter flask to do our reaction in, and 2 30 milliliter flasks to hold our solutions, one being our HCl and the other one being our PVA solution. For our chemicals, we are going to have our PVA solution with a known molecular weight. We're also going to have our other 4% PVA with a different molecular weight. We're going to have our 4% borax, our 1 mole hydrochloric acid, and we are also going to have our blue indicator. Now, your professor may have options for you, whether it's blue or yellow, but it's pretty much so you can just see how the reaction proceeds. Before we move on, I am going to recap on how to use a volumetric auto pipette and how to use a microburette. As I said previously, I will now demonstrate how to use the volumetric autopipette and the microburette. First, I will demonstrate to you how to use the volumetric autopipette. Now, if you see the volumetric autopipette, you can see that right here has a curve. Now, this curve right here serves for a purpose, and that is so we can rest it here on our palm gently, and it's very comfortable to hold. Now that you know how to hold it, I will show you how to insert the tip of the autopipette. Now, to put the tip, you do not have to be extremely aggressive with it, but if you put a little bit of pressure down, tip will just stay on like this. Now, if we were done transferring some fluids, let's say we just transfer some fluid, to get rid of our tip, we would press this button right here. And that button would just eject our tip, like so. Now, in order for me to demonstrate how to actually use it using liquids, I've prepared a small flask with just DI water and another flask to serve as the flask in which we're going to transfer our solution. For anything, we need to, before we even transfer any fluids, we have to make sure that our volumetric autopipette is set to the right volume. To do so, on the side, we are going to see what is called the thumb wheel. But the thumb wheel, we can change the volume to get exactly the measurement that we want to. Just 1 second, I will zoom in and show you what happens when you turn this thumb wheel. Now that it's in frame, you can see that if I turn it to one way, you can see how our volume changes. For this experiment, we wanted to read 1 milliliter. Right now, we set it below 1 milliliter. Now to set it back, what you want to do is go counterclockwise until you go a little past 1. Once you've gone a little bit past 1, then you want to return to 1 milliliter just to make sure that it's set to the correct volume. Now that our volumetric autopipette has been set to the right volume, now I can show you how to transfer solutions from flask to flask. Like I showed previously, I will now put another fresh tip in, like so. I will close this, put it aside. The button all the way to the top is called a plunger. Now, the plunger has 2 stops. That's the first stop, and then I could press a little bit more, and that's the second stop. That is very important because depending on whether you are barely getting your solution out of the first flask or if you are already transferring into the second flask. Now, I will demonstrate and explain to you what I mean. Now, in order to get the solution from the first flask, I will go to the first stop like this, and then pull back. I do want to mention that whenever you are using the volumetric autopipette, you do not want to be holding it sideways like this. You always want to hold it upright. But for the purpose of this demonstration, for you, and so you are able to see, I will hold it sideways. Now, like I previously said, for you to get your solution out of the first flash, you're gonna go down to the first stop. You're gonna put your volumetric auto pipette into your solution, making sure that it is inside of your solution. You will let go of the plunger, and your volumetric auto pipette will extract exactly 1 milliliter of your solution. Now, once you are ready to transfer your solution to your secondary flask, you are gonna press down on the plunger to the first stop, and then all the way to the second stop, to make sure all of your solution has been transferred. Now, once again, for you to get rid of your tip, you just press this button on the side, and it will eject the tip. And that is how you use a volumetric auto pipette. Now I will demonstrate to you how to use a micro burette. This is the micro burette. Now this equipment we will use in order to titrate our acid into our slime in order to kill our slime. To do so, I will demonstrate to you what it looks like. Maybe a little hard to see, but you can see that the readings go by 0.1 and read all the way to 1 milliliter. That is very important because we want to be as accurate as possible and get it to 1 milliliter in order to know how much of our solution we are titrating into our slime. Now, in order for me to show you how to use this, once again, I will bring in my two flasks, one just holding our DI water, and our secondary flask being our flask in which we're going to transfer our solution. Now, for you to be able to transfer your solution properly, or in this case, how to titrate your solution into your other flask, you will have to practice how to properly fill the micro burette. Now, once again, we will insert our micro burette inside of our solution, making sure that the tip is under the liquid. Then we will pull away past 1 mil. Now that we have a reading a little bit past 1 mil, let me zoom in. Maybe a little hard to see. Let me get this flash out of the way. Not sure if you're going to be able to see, but you should see that there is some bubbles right there on the tip of the micro burette. Now, we don't want those bubbles there. So I will show you how to get rid of that. For you to be able to get rid of all the air pockets, you're gonna invert your micro burette, and you are gonna gently tap on the side, like so. Now, once you've done that, all of the air bubbles should go to your tip of your microburette. Once you have that, then in another flask that does not matter, take some of your solution out and bring the reading down back exactly to 1 mil. Once you have an exact 1 milliliter reading, you are ready to titrate. You want to make sure that in your lab notebook, you write down your initial volume of your microburette and your final, whether it is that you use it all up or how much you use. If you only use half, then you want to get the most accurate reading that you can from your microburette. In this experiment, we will titrate drop by drop, like so. 1 drop, we will mix our solution, and if we need to, make another drop. Some cases, you might have to do maybe half a drop. You're going to titrate drop by drop. And once you've practiced enough, you should be able to do it with ease. And that is how you use a microburette. We will now begin part 1 of our experiment. Now, I have laid out all the things we're going to need for part 1. Now, as you can see, I have used my graduated cylinder to measure out exactly 50 milliliters of our PVA solution. I've also transferred some of our borax into a smaller flask just because we do not want to contaminate our original sample. We want to make sure that we just grab about what we're going to need. That way, in case we contaminate it or anything, we just contaminate the portion that we took out and not the whole thing. We're also going to need our blue indicator, our reaction flask, where we're going to react everything. We're going to use our 2 tongue compressors and obviously our volumetric pipette, auto pipette. Now, to begin, we are going to grab our reaction flask and we are going to pour we are going to transfer our measured volume of PVA. Now that we've transferred our 50 mils of PVA into our 250 milliliter reaction flask, now we are going to add about 10 drops of our blue indicator. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Once we've added it, then we can just set it aside. Now that we've added our blue indicator, our next step is going to be to write down any observation that we can notice right now before adding our cross-linking agent borax. Now, using one of our tongue compressors, we are going to mix it, and we're just going to observe anything we may see. Mix it. Now, I'm going to zoom in. Our solution seems a little thicker than water, but not super viscous. Very fluid-like. It has kind of like a lime green color. But properties seem very fluid-like. Now that we know that, and we've wrote down our observations, our next step would be to add our cross-linking agent borax. To do that, we're going to be using our volumetric auto pipette. The next step is very important. As soon as we've added our 1 milliliter, our first 1 milliliter of borax, we want to make sure that right away, as fast as we can, we mix our reaction flash to make sure that we mix our reactants properly. Now, just double checking that our volumetric autopipette is set to the right volume, we can begin our experiment. Closer. First stop, second stop. Now we're going to set this aside and mix right away. Now you want to make sure that you're mixing aggressive, but we want to make sure that we mix as well as we can. You can do circles, and then go from circles to up and down, side to side, and continue like that. Now, even though you've only added 1 milliliter, you should see some type of observation or change in your liquid. You can see how it's getting a little bit thicker. It's not so much super liquidly like a liquid anymore. Kind of gaining other properties. Now, we're going to add another milliliter of our cross-linking agent. Once again, as soon as we add it, we want to make sure that we mix our solution. Good. Once again, you want to go circle, 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 up and down, circle, circle. Okay, using our secondary tongue compressor, we want to get whatever's stuck on the tongue compressor off. Continue mixing. Now that we've added our second milliliter of borax, we can clearly see that now the properties have changed. Now, between the polymer strands, they are reacting with one another, and we are seeing more of the properties of our slime. But we still need a little bit more. With that said, we are going to add 1 more ml of our borax. Again, circle, 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 up and down, circle, circle. Make sure that it mixes as well as you can. One thing I do want to make clear is that with any change or observation that you make, you want to make sure that you write it down, because it is very important how you see how the properties are changing as the polymer strands are reacting with one another. Now, just keep mixing, keep mixing, keep mixing. You can see very clearly that what we have a little bit. Now, with any case, if your slime does not look like this and still pretty much holds the property a little bit more like a liquid more than a slime, then in your instructions, it does say you can add 0.5 more of your borax to help your reaction. But in our case, adding 3 milliliters of our borax was just enough to get our polymer strands to react and create our slime. So you can get a better understanding of the properties of our reaction. You can take it out of the reaction flats. Just make sure you do have gloves. And take note of all of the properties. How you can stretch it, rip it, and then it very easily comes back together. Now, that you've written any observations that you can see, we can move to part 2 of our lab. In part 2 of our experiment, we are gonna kill our slime. To do so, we are gonna use our microburette with HCl. Like we did with borax, we wanna make sure that we transfer some of our acid to a flask and not use the original acid in its plastic bottle. That way we don't contaminate it. Now, like I showed you previously on the video, you wanna set up your microburette to the right volume and write down on your notes exactly where it's reading. That way you can get a more accurate reading of how much of your acid you titrated into your reaction flask. In order to kill your slime, you're gonna add 1 drop at a time And every time you add a drop, you're going to mix it very well with your tongue compressor. You're going to add drop by drop by drop until you've essentially broken down all of the reactions that happen between the polymer strands. In your pre-lab, you should have calculated an estimate of about how much you're going to add of your acid. But make sure you still add drop by drop. Now I will fast forward just because if I do it drop by drop, this video is going to take longer than it should, but I will skip forward, that way you can see what it should look like once you've killed your slime. Right about now, I've added about 2 milliliters of our acid, and here you can see that our slime has changed properties. It is slowly killed the more acid that we add. Now I will fast forward again once I've added 2 more mils of our acid. Now titrated a total of 4 milliliters of our acid, and not only can we see a color change, but the properties of our solution are turning back into a more liquid form. We can still see some of the consistency of our acid, but we can clearly see that it is reverting our reaction. After adding about 0.78 milliliters of our acid, our slime has officially died. As you can see, the color has changed. The consistency has changed too. Now it's a very liquid. And we have killed off our properties of the slime. Now, for part 3 of this experiment, we are going to proceed and revive our slime once again using our cross-linking agent borax. And theoretically, we should use about the same amount that we use in part 1, or you may have to add a little bit of more borax depending on how much acid you titrated into your reaction flask. We will now proceed to part 3 of our experiment. Now that we have our slime fully killed with 1 molar HCl, now we're going to use our borax once again and our volumetric pipette to revive our slime. While doing so, we're also going to take notes of our observations and any change in properties that we might see. This is what our solution looks like after adding just 1 milliliter of our borax. After adding 2 milliliters of our cross-linking agent borax, our solution is starting to make chemical bonds with itself, and our slime is beginning to revive. Now that I've added 2.5 milliliters of our cross-linking agent borax, our solution is getting better. It's forming more of a slime. After adding 3 mils of our borax, our slime is looking like this. For the sake of the experiment, I will not continue adding borax because I think our slime is resurrected as best as we can do. Now we will proceed to part number 4, where we will be using another 4% PVA, but with a different molecular weight. Here we can see our two PVAs side by side. Now that we use our PVA on the left-hand side, we will be repeating steps 1 through 3, but with our new PVA on the right-hand side. Now that we are beginning part 4, since part 4 is very similar to part 1, I will do part 4 a little bit faster while still allowing you to see observations. I have now measured 50 milliliters of my new PVA, and I will pour that into my reaction flask. Just as we did in part 1, we will add 10 drops of our indicator. As of now, our new PVA is behaving similar to part 1, and now we will begin adding borax. After adding 1 milliliter of our borax, our solution has turned blue and turned a little more viscous, but still holds no properties of slime. After adding 2 mils of our linking agent, we can see that the color has not changed, but it is more gooey. After adding our third mil of our borax, color has stayed the same, but our properties have changed. We can see that it's more gooey-like and is getting closer to a slime, but not quite. Since we are already at our 3 milliliter mark, I will add 1 more ml just to see if any change. But since we have a smaller molecular weight, we would expect that it will not form the same slime that we formed with our higher PVA. After adding 1 more ml of our borax, we can see that there was a slight change, but it has not fully formed our slime. We will now proceed to killing our slime. After adding 0.4 milliliters of our 1 molar HCl, our solution has lost all properties of the slime and has even further changed color back into its original yellow. Now that we've added a total of 0.5 milliliters of our acid, our solution has completely reverted the reaction and we have fully killed our slime. We will now attempt to revive our new slime using borax. After adding 1 ml of our borax, we can see that our solution it has turned green, yet no properties of our slime is present. Now that we've added 2 milliliters of our borax, we can see that our solution has changed colors and is turning more blue. Our liquid is also changing and it is more viscous. After adding our third ml of borax, we can see that there wasn't much change. And it is very unlikely that we will make or resurrect our slime once again. That concludes part 4 of this lab. Now that we have finished our experiment, it is time to clean up. All of our glassware, we will make sure that it's properly cleaned with soap and DI water and left to fully dry. Any solutions left over need to be properly thrown away, either in a labeled container or down the drain. If ever in a doubt, please ask your professor. And if any solution is to be thrown away in a labeled container, they will be found in a hood.